Hello everyone, my name is Erish Filipino and this time we're going to tackle about geometry. So what do you think is geometry? The word geometry comes from two Greek words, geo, which means earth, and metrin, which means to measure. So originally geometry was the science of measuring land. Who started geometry? The Greek historian Herodotus, who lived in the 5th century BC, said that Egyptians were the first people to develop geometry. But other ancient civilizations like the Babylonians, Hindus, and Chinese also had a lot of knowledge about geometry. How did early people do geometry? Back then, geometry was not exactly a science the way we think of science today. People didn't use exact rules or proofs. Instead, they learned by experimenting, looking for patterns, and making good guesses. Sometimes they were right, and sometimes they were wrong. So, examples of early geometry. The Babylonians around 2000 to 1600 BC thought that the circumference of a circle was three times the diameter. They also thought that pi was equal to 3. The Egyptians around 1800 BC had a better guess for pi. They thought it was about 3.16. They also figured out that the formula for the volume of a special kind of pyramid. Both the Babylonians and the Egyptians developed some rules for figuring out areas and volumes, but these rules were not always accurate or based on logic. So, what the Greeks did differently? The Greeks were the first people to develop geometry into formal science. They came up with proofs to show why things were true in geometry, not just guesswork or rules based on observation. The Greeks changed the rules. Before the Greeks, people learned about geometry by experimenting and making guesses. The Greeks were the first to develop a logical system for geometry based on proofs. So, who was Thales? Thales of Miletus was an important early Greek mathematician. He is sometimes called the father of geometry. Thales is famous for proving the theorem that says that the base angles of an isosceles triangles are equal. Thales and the Egyptians. Thales traveled to Egypt and learned some of their geometry. He may have even learned the Pythagorean theorem from the Egyptians. The Pythagorean theorem is a famous theorem in geometry that says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, more Greek mathematicians. Pythagoras was another important Greek mathematician who came after Thales. Pythagoras and his followers, the Pythagoreans, made some important discoveries about geometry, music, and numbers. They also discovered perfect numbers and odd and even numbers. Hello everyone, my name is Irish Filipino and today we're gonna talk about abstract algebra. So here are some key concepts of abstract algebra. So abstract algebra is a branch of mathematics that studies the properties and patterns within algebraic structures, groups, rings, fields, and etc., rather than focusing on traditional numerical calculations. Algebraic structures is sets with defined operations that follow specific rules and patterns. These structures are abstract because the elements within them are not strictly numbers. Examples are groups, rings, fields, vector spaces, and modules. Mathematical abstraction. This is the process of identifying common properties of patterns across different mathematical systems, then creating generalized frameworks to study them. So let's proceed to historical context. Early 19th century. So the need to solve higher degree polynomial equations drove exploration of new areas of algebra. Everest Galois pioneered the concept of groups to address these equations. Then Carl Friedrich Gauss developed modular arithmetic, which shares properties with groups. And new non-Euclidean geometries emerge, and groups help them analyzing it. Evolution of abstract algebra. The power of groups as a unifying tool led to the development of more abstract structures, rings, fields, and etc. Careful refinement of definition ensured these structures were both broadly applicable and insightful. So, significance of abstract algebra. In Foundation for Modern Math, abstract algebra provides the underlying principles and structures used in many areas of advanced mathematics. Then, wide-ranging applications. This is initially theoretical, so abstract algebra now has applications across in physics, chemistry, computer science. Evolving field, the usefulness of abstract algebra continues to grow with new applications being discovered regularly. So, other names about abstract algebra is also called modern algebra or simply algebra in advanced mathematics context. And prerequisites to study abstract algebra, one needs to be a solid foundation in traditional algebra, experience with mathematical proofs, capacity for abstract thinking. And so I think that's all about abstract algebra we're gonna that I tackled. So that's all. Thank you.